Okay, so our last unit here is going to be about solutions, what happens when we mix things together. And to understand solutions, the first thing we have to understand is water. Okay? So water molecules, H2O. The H is hooked to an O, is hooked to another H. Okay? So, and oh, remember that this is actually a bent molecule because of the two lone pairs there. And when they make these bonds, the O is more electronegative, so the electrons get pulled towards the oxygen. And that gives oxygen a partial negative charge. Remember, we use that delta sign negative. And the hydrogen's a partial positive charge. And because of its bent shape, it's polar. It's got a positive end and a negative end. The oxygen end is positive. There's negative, the hydrogen end is positive. And if you remember right, because we have oxygen hooked to hydrogen, not only is it polar, it can make strong hydrogen bonds. Okay, so water molecules are attracted to each other really, really well. Hydrogen bonds are the strongest intermolecular force. Water can make two of them, one off each hydrogen. So water molecules are stuck to each other better than other molecules the same size. Remember, the bigger the molecule, the better they stick. But water sticks together unusually well for something so small. That leads to a property called surface tension. Like water acts like it has a skin. You ever tried to put pepper into soup? It just sits on top of the soup and never goes in. Like there's a skin stopping the pepper from going in. That's what we're talking about here. Okay? Because that surface tension, water forms round drops. It's all about hydrogen bonding. Because water has a positive end and a negative end, the positive end of one water molecule can hang on to the negative end of the other water molecule, so they stick together. So there's a hydrogen bond between the negative end of this molecule and the positive end of that molecule. One water molecule hydrogen bonds to another. Okay? But that's only two water molecules. If you got a cup of water, you got billions and billions and billions of these water molecules, and they can actually do it in every direction. So this one water molecule can be attracted to water molecules on every side. So a water molecule in the middle of the solution is pulled in every direction. These molecules are all being pulled towards each other, trying to get as close as they can to each other because they're attracted. At the surface, they're not pulled in every direction. They're only pulled in closer, pulled into the water and closer together. There's nothing pulling out. So this water molecule is only being pulled inward and together. So these water molecules at the surface are going to crowd together. And that's going to hold the molecules together. And that causes surface tension. So if I put a big piece of pepper, a pepper molecule here, it can't get in between the water molecules because the water molecules are squeezing together. It can't get in between those, so your pepper never sinks. Here's another explanation from Khan Academy.
If you took a glass of water and a needle, and you took that needle and you very carefully dropped it on the water, it would stay there. And it's not because it's floating. This needle would not be floating on the water. This needle is more dense than water, and we know that if it's more dense, then it should sink. So it's not floating. It's actually just sitting on the surface because there's surface tension. Water is a liquid that's capable of having a significant amount of surface tension. And you know it's surface tension because if you were to come in here and exert a little force down, breaking the surface tension or pushing this needle just below the surface, then it would sink. It would sink like a stone and just drop immediately to the bottom of the cup. So why does water have this property of surface tension? It has to do with the fact that the water molecules within this liquid are attracted to each other. This water molecule can form hydrogen bonds with the other water molecules around it, and it gets pulled toward them. And there's a term for this. We call this cohesion. So the fact that water molecules and other liquid molecules are attracted to each other is called cohesion. But what does this have to do with surface tension? Well, the key is these water molecules would like to bunch together. They want to group together if they can. So what would this water molecule do? I mean, which way is he going to go? How does he pick which one to group with? There's a problem. Here in the bulk of the liquid, he can't decide. Or in other words, let's just say it got pulled toward this molecule. Well, it's also getting pulled to the left by all of this. By this one's pulling it back to its original position. This one's pulling it back to its original position because there will be a component of that force that'll point in the direction of its original position, as well as this one to the left. So these are restricted. These molecules here in the bulk of the liquid have too many other water molecules around them dictating where they need to be, because if they tried to get displaced, it'd pull them back to that position. However, at the surface, there's no water molecules above them. These are freer. They're less restricted. So that allows these water molecules on the surface to group together a little better, form stronger, tighter bonds, closer spacing at the surface in such a way that they form a tension that's not present in the bulk of the liquid. Yes, these water molecules down below will prevent them from just grouping into one big clump in the center, but since they're less restricted, they can form these tighter bonds here at the surface, and this allows it to support a pressure from above. So this allows it to support a certain amount of weight, which allows the needle to rest on the surface. A few practical applications of this, one clinical: if there's bile present in urine, you could detect its presence because it lowers the surface tension of urine. So it gives you a test of whether the liver is metabolizing things the way it should. Another application is if you go camping and you're in the tent, it's raining, and the tent gets raindrops on it. Most tents will keep the water from seeping through, but you're going to be tempted. You're going to be sitting in here, you're going to be like, that looks cool, and you're going to touch it, but you're not supposed to touch it, because as soon as you touch it, you may break the surface tension. And once you break the surface tension, that water is dripping into your tent from that spot that you touched it, and you're probably not going to have a good night. So resist the urge to break the surface tension on your tent if it's raining out. And when you wash your hands, when we use detergents, if you washed your hands with just regular water and that's it, sometimes the surface tension's too great. These water molecules are too bound to each other. They form too big of a clump. It doesn't look like it. It looks perfectly smooth. But on a microscopic level, the water's not as diffuse as it could be. It's forming these clumps because the water has cohesion and it joins together. But if you add a little soap to the scenario, that breaks the surface tension. It lowers the surface tension, which means these water molecules don't clump together as much. And if they're not clumping together, they can get into the small cracks, which kicks out the dirt in your hands, and this water is better able to penetrate into the smaller cracks and get where it needs to go. So surface tension is due to cohesion between the water molecules at the surface of a liquid, but water molecules aren't just attracted to each other, they're actually attracted to the container too and other materials, and that's called adhesion. So the fact that water molecules are attracted to other materials as well is called adhesion. So what happens is this water molecule isn't just attracted to the other water molecules, it's attracted to the wall, and these water molecules climb the wall a little bit. So that's why you'll see when you fill a container with water or you're measuring an amount of liquid in a small burette, it's not perfectly level at the surface. It actually forms this kind of shape like that. This is exaggerated, but the sides will be a little higher than the middle. So you have to be careful when you're measuring. This is usually called the meniscus, and it's caused by the adhesion, the attraction of water molecules to the container that it's in. This adhesive force, this adhesion force is important. It causes something called capillary action. So let me get rid of this. If you have a container with liquid, or say water, and you took another container, you put it in here like a straw. If you just stick it in, what you'll see is that because the liquid is attracted to the walls of this inner container, it doesn't just stay at this level, it'll rise above. It pulls this up a little bit above the surface level of the water. And if you took an even smaller diameter tube and put it in there, the smaller the tube, the greater this effect, and you'd get this water rising to an even higher level within this tube due to the adhesion to the walls of this container. And the name for this effect is capillary action, which is important in a variety of biological and non-biological examples where fluid is being aided in transport partially by the attraction to the walls of the container or the tube that it's flowing in.
Water drops around. Okay? The reason why water drops around is because a water drop is pulled inward. So if I had another water molecule here, it wouldn't stay here. It would be pulled into the water drop. And that makes our water drops round. Because if you had tried to have a corner, this water molecule would be moved inward. It wouldn't be pulled left, it wouldn't be pulled right, it would only be pulled inward. And that would make it join the other water molecules. So if you ever watch while things get wet, the drops run into each other, they get bigger, they stick to each other, they always have round edges. That's because of surface tension. Now, if you do it on a car, they're flattened out, not perfectly round, because the gravity flattens them out, so you get flat round drops. Okay. Now, all of those previous ones were about cohesion. Co, together. Hesion, sticking. So cohesion means they're sticking to themselves. So this is water molecules sticking to water molecules. Now we can talk about adhesion. Adhesion is when something sticks to something else. The glue on the back of tape is called an adhesive. Adhesive means it sticks to other things. And one of the things it can stick to is glass, because glass has polar molecules. And those polar molecules attract the water molecules. And if you look, if I put a water molecule next to glass, there's glass below, glass above, and so some of the pull is going to be upward. And that gives curved water up along the side of the glass. So if you look at your straw, you'll find the water in there looks like this. Every time we use a graduated cylinder, it looks like that. That shape, that is the meniscus, that curved shape that it takes. Now that all happens because water grabs onto to the glass. If something couldn't grab onto the glass, if I had glass where it couldn't grab on, there was no attraction between the wall and the glass, then a molecule right here wouldn't be attracted to the glass, it would only be pulled inward. And what I get is a meniscus the other way. This molecule wants to be close to this, not to that. So you get this shape if there's adhesive forces, and you get that shape if there's no adhesive forces. So in glass, it looks like that. In nonpolar plastic, it looks like that. Depending on what you put the water in, which way the meniscus grows. Because glass it can hang on to, so it's going to be pulled up. Plastic is nonpolar, it's got nothing to hang on to, so any water molecule here would only be pulled in, so that's going to make it curve that way. So I've got a couple other videos to show you, and from those you'll be able to answer the homework questions. Tomorrow we'll talk about what happens when you put water together with stuff.
Vamos a soltar unas gotas de alcohol sobre esta superficie lisa de vidrio. Y ahora lo mismo, pero con agua en vez de alcohol. La tensión superficial del etanol es 1/3 de la del agua. Moja mucho más que el agua. En cambio, la tensión superficial del mercurio es 6 veces superior a la del agua. Es por ello que el mercurio, a pesar de ser un líquido, no moja.